Good evening, all. Today we will be solving traveling salesman problem using dynamic programming. So, in dynamic programming, we will calculate complex problems by breaking them down into similar subproblems. By solving each subproblem only once or storing the results, it avoids redundant computations leading to more efficient solutions for a wide range of problems. For example, if we see Fibonacci series of 4, uh, let me write here something. Oops. For example, if we see Fibonacci series of 4, f of 4, now we store 2 here and 3 here, since 2 is the smallest child node and 3 is the largest child. So we store it on the left side and we store it on the larger number we store on the right side. Therefore, likewise, traveling salesman problem is a graph computational problem where the salesman need to visit all the cities, okay, using the nodes in the graph. So the graph looks like this. For example, 1, 2, and so we have 3 vertices and all the 3 vertices are connected. For example, these are all cities. Now he has to travel 1 to 2, 2 to 3, and he has to reach again the starting position. So for these cities, now what are the possible ways to travel this graph? One, he can go first 2, then he can go to 3. Likewise, if he starts from 2, he can go 1, then 3. Okay. So likewise, the solution that is needed to be found for this problem is the shortest possible route in which the salesman visit all the cities and turns to the original city. As I said, he starts from 1, then visits 2, then 3. If he starts from 2, he goes to 1 or he goes to 3. So likewise, traveling salesman problem is a graph. So let's see the example first. Now here, if you look at the graph below, consider that the salesman starts from vertex A. Okay, he starts from vertex A. They need to travel through all the remaining vertices B, C, D, B, C, D, E, F. Okay, few there are various approaches to find the solution to traveling salesman problem. So these are the solutions. Navy based approach, we can solve this problem by greedy approach, since we can, if we divide this graph. So basically what is greedy approach? Greedy approach is a divide and conquer approach. It divides the problem into subproblems and it counts the solution. Therefore, through dynamic programming approach, Ricardo, I think, तार कहाँ बोला. So the dynamic programming, we have to solve this by dynamic programming approach. For example, now for this graph, so at first we have to travel from A to B. then A to B to C, then A to B, B to C, C to D, then A to B to C, C to D, D to E, A, B, C, D, E, F. So like he travels from, wait a second, he travels from A, then B, then C, then D, then E, and F. At last, he reaches the origin state with cost of 34. Okay. So traveling salesman problem using dynamic programming. So here we have given an example. So how to solve this? Let's check once. So this is the example. For this example, we will see the answer here. So traveling salesman problem. We have given a graph. We have a graph that 1 to 2, 2 to 3, 3 to 4, and it is a directional graph. And the values of the graphs are given in this matrix. 1 to 2. If you see 1 to 2, it is value 10. Likewise for all 2 to 3. What is 2 to 3? 2 to 3, 9. Likewise 4 to 3. 4 to 3, 9 again. 4 to 1. 4 to 1, it is 8. So for this graph, we have to draw a binary tree for this at first. Now, if we draw, what are the possible ways? What are the possible ways we will see once? He can go first 1 to 2, okay, then 2 to 3, then 3 to 4, okay. At last, from 4 to 1, he can reach. Now, let's calculate the cost. What is the cost from backside? Now, what is the cost from 1 to 4? What is the cost from 1 to 4? It is 8. So here we have written the cost 8. Now, what is the cost from 4 to 3? 4 to 3. It is 4 to 3. It is 4, 3. It is 12. So 12 plus 8, it is 20. Now 3 to 2. What is the value 3 to 2? Again, here the value of 3 to 2 is again 9. So we have 20 here again. 20 plus 9. Okay. Now 2 to 1. What is 2 to 1 here? 0. 2 to 1, 0. So total cost here is 25. Okay. Yeah. Now we got. Likewise, another route from 1 to 2, 1 to 4, 1 to 3. Similarly, he can travel first 1 to 3, 3 to 2, 2 to 4. Then 3 to 4, 4 to 2. Again, he can travel 1 to 4, 1 to 2, 2 to 1, 3 to 1, 4 to 3, 3 to 2, 2 to 1. Now we have to calculate from last. All the values we have to calculate from the last. If we see, we get cos 25, 25, 23. And if we calculate 10 plus 25, it is 35. 15 plus 25, we get some answer. 20 plus 23, we get 43. So which is the minimal cost? That route we will select. So the minimal cost is 35. Okay. 25 plus 10. The cost from 2 to 1 is 1 to 2 is 10. Okay. 2 to 1. Therefore, we select that route is the best optimal way using dynamic programming. So for that route, we can calculate from a formula also. So to calculate through a formula, we have g of 1 comma 2 comma 3 equal to minimum k. Now here we take how I will explain all these things, how we should take. Then what is c, what is 1k, again what is this. We will calculate using this formula. Let's see how to calculate using this through a formula. Now we are traveling from, if we choose, we are traveling from 1 to 2. The starting vertices is 1. The remaining vertices are 2, 3, and 4. That we have to write here. If we are starting from 1, that is the value of I. So I equal to 1. Then S equal to 2, 3, 4. And I belongs to K belongs to S. So S values we already know 2, 3, 4. 2, 3, 4. We have noted. Then we have to calculate C, K plus G, and the values we have to substitute in this formula, given formula. Now after going, so first iteration completed. We have calculated for 1. Next iteration for 2. So we have already known 1. So now we are calculating for 2. So I value is 1 plus 1, 2. Then we have 3, 4 in the bracket. Earlier we started with 1, so we wrote 2, 3, 4. Now we started with 2, so the k value became 2. Then we left with 3 and 4. Likewise here, we started with 3, the remaining values are 2 and 4. Then 4, the remaining values are 2 and 3. Likewise, if we substitute these values what we got in this formula, we will get the minimal way. Now the second iteration. So if we reach to the second iteration, again here from 2 to 3 we can go, 2 to 4 we can go. Now the value will become 2 comma 3 plus the k value becomes 3 and the only left with 4. Likewise, we have to calculate for all the nodes. Then if we plus all these things, 2 plus 3, 2 into 3, 6 plus 3, 9. Here 10, 13. If we see 2 comma 3, what is 2 comma 3 in the matrix? 2 comma 3, it is 9. So we have to write 9 here. Likewise, we have to write 9 here. Now we also got what is 1 comma 2. What is 2 comma 4? 2 comma 4 is 2 comma 4 is 10. So we got value for here 10. Now we have to get value for 1 comma 3. What is 1 comma 3? 1 comma 1 comma 3. It is 15. So we get value for 15 here. 1 comma 3, 15. Likewise 1 comma 4, 20. So likewise, we have to calculate all the values until we reach. Then we get the minimal value from here. That route we will choose as the shortest route. See, if you see here, we get 35, 20. If you see, we get total value here 35. So we can solve this problem into two ways. At first, if we start from 1, all the vertices we have to visit and we have to go to the starting vertex 1. Likewise, also if we calculate, we will get 35. If we solve using this formula also, we will get 35 here. So we have seen traveling salesman problem using divide and conquer approach, and we have listed all the cities, and we have calculated the shortest path using dynamic programming.